Assalamualaikum everyone. Welcome to Mathematics with Shahab Yaqub. We are starting with Algebra and this is lecture number 21. And this time the focus is on inequalities. So first of all, what is an inequality? When we talk about an equal sign is this. But there are four possible inequalities that we deal with. The first inequality is this thing that is greater than. The second inequality is less than. The third inequality is greater than or equal to. And the fourth inequality is less than or equal to. That means if I write x is greater than 1, that means 1 is not included. All the other values greater than 1 are included. If I write x is lesser than 2, that means 2 is not included. All the values lesser than 2 is included. It could be 1.999, it could be 1, it could be 0, it could be -1, and so on. Similarly, greater than or equal to. So x greater than or equal to 1, yes, 1 is included this time and all the other values greater than 1. And similarly, if I talk about less than or equal to, so that is x is less than or equal to 3. 3 is inclusive and then values lesser than this. Now, first of all, when we talk about greater than 1, so let me draw a number line like this. So if I write x is greater than 1 and there is 1 over here, so this is greater than 1, this is an empty circle. So this is greater or lesser is empty circle. If I write x is lesser than 3, so this is 3, x is lesser than 3, we will go to the left. So greater is right, lesser is left, and it's denoted by an empty circle because the value is not included. But if we talk about greater than or equal to, let's say greater than or equal to 5, x is greater than or equal to 5, then over here there is 5 and this value is inclusive. If we talk about lesser than or equal to -1, then -1 is over here, this value is inclusive, it's a solid circle and we are going to the left. For lesser, for greater, we are going to the right. And it says greater than or equal to 1. This can also be written as at least. Greater than or equal to can be written as at least. Less than or equal to something, this can be written as at most. So remember the word at least, remember the word at most. So I hope this is all good, all clear. Let's look at the first example. The example says that solve the following inequalities. Let me just look at the WhatsApp if there is any question. The number line concept, that from the right values increase. Okay, let me explain it a bit more. When we talk about, let me just take this question and paste it on the next page. It's right over here. And over here, if I write, let me draw 4 number lines. So first of all, I'm drawing 1 and then 2 and then 3 and then 4. Let me label x is greater than 4. So there over here it's 4, it's 5, the numbers are increasing. Greater than 4 means greater than 4, bigger than 4. If I write 7 over here and if I write x is lesser than 7 means go to the left. So greater means right, lesser means left. And this is an empty circle, that means the value is not included. So far so good. And similarly, if I write x is greater than or equal to, let's say 1. So this is 1, this is 2. Greater than or equal to 1. So that is how it can be written. You can transform from an inequality from a number line, this is called a number line, to an inequality to number line. Similarly, let me label over here, this is 7, 6, 5 and so on. And if I write x is lesser than or equal to 10, so therefore this is 10, this is 9, this is 8, lesser than or equal to 10, solid circle going to the left. This can be written as at least. This can be written as at most. I hope I've made it all good, all clear. Just acknowledge. So now let's look at this question. Just read through it so I can have my sip of tea. Now it says solve the following inequalities, show this thing on a number line. It says x plus 4 is lesser than 8. So you have to make x the subject. So part A, x plus 4 is lesser than 8. Take 4 to the other side. X is lesser than 8 minus 4. X is lesser than 4. So look over here. It's an empty circle and we are going to the left. You can draw it on the number line. You can draw it on top of the number line. So I can draw it like this. And let me draw a line like this. Let me draw a circle like this. And that is like this. So this is 4 and it's an empty circle. Similarly, 1 plus 2x is lesser than or equal to 4x minus 5. Part B. 1 plus 2x is lesser than or equal to 4x minus 5. 2x minus 4x is lesser than or equal to minus 5 minus 1. Negative 2x is lesser than or equal to negative 6. Now let me focus on this one and let me solve this thing in two different ways. So this is method 1, this is method 2. So this is method 1. That is, you shift the places. So the inequality remains as it is. We bring the 2x over here, we bring this 6 over here. And then we make x the subject. So make x the subject dividing by 2. So 6 over 2 is 3. And you read it from the perspective of the variable. So the perspective of variable. From the perspective, you can see that x is greater than or equal to 3. So therefore, if I draw a number line, and that's right over here, and this is 3, and this is greater than or equal to 3, that's a solid circle and we go to the right. That's how we label it. And that is exactly what they have labeled. This is 3 going to the right. Now let me also focus the other method because that concept is needed. You should be aware of it. That is method number 2. That means if the coefficient of variable is negative, and when we remove the negative sign, inequality flips. Irrespective of whether the other side is positive or negative. So let me just explain this. We have over here this inequality that is right over here. Negative 2x is lesser than or equal to negative 6. Negative 2x is less than or equal to negative 6. We already have the correct answer right over here. That is x is greater than or equal to 3. I can write this thing as x is greater than or equal to 3. So now let's apply this knowledge. Divide both sides by negative 2. And this inequality will flip. So this is greater than or equal. This becomes x. This becomes positive 3. X is greater than or equal to positive 3, which is definitely the same answer as above. So this is 3. Solid circle greater than or equal to 3. So now if you have understood this concept, I want acknowledgement for all the students out here. So the concept of negative coefficient of variable and we are talking about inequality. Now someone said, acknowledge, but can you please tell again method number 1? And other people, you should also be acknowledging it. Method number 1. Method number 1 is simply this. I just shifted the sides. I took negative 2x on the other side, negative 6 on this side. This negative becomes positive. This negative becomes positive. Divide by 2, divide by 2. Maybe I skipped this step. You should not. Divide by 2, divide by 2. Therefore, x is greater than or equal to 3. So from the perspective of x, x is greater than or equal to 3. You go to the right. That's all about it. Now, these are some questions that we need to try out. Let me mark it for you. And let's try this out. Question number 1A, 1E. This E over here and this over here and this over here. Try this out and I'll pause the recording. So now let's look at the solution of this. I just want to time myself at 6:40 and let me just try out these questions. So first of all, question number 1, part A, x plus 9 is greater than 14. Therefore, x is greater than 14 minus 9, which comes out to be how much? That comes out to be 5 and 4. This comes out to be 5. The next question, our number line, very simple. Let's mark 5 over here, empty circle, go to the right. 1 part E. That is 18 is lesser than x plus 2. I can write this thing as x plus 2 is greater than 18. Isn't this a nicer way of writing it from the perspective of the variable? So x plus 2, you read it like this. X plus 2 is greater than 18. So therefore, x is greater than 16. Again, a number line. This is 16, empty circle, going to the right. What about question number 2? Question number 2, part E. It says 4x is lesser than negative 16. Now the coefficient of x is positive, so it doesn't make a difference. The inequality won't flip. So therefore, I'll write x is lesser than minus 4. Therefore, this is negative 4. X is lesser than negative 4. And then we have question number 3, part E. So question number 3, part E, let me write it down. Minus 1 is lesser than x over 8. Minus 1 is lesser than, I think, greater than x over 8. And let me write down part G, x over 1.1 is greater than or equal to 10. X over 1.1 is greater than or equal to 10. Now this one, let me write it from the perspective of this. X over 8 is lesser than minus 1, x is lesser than minus 8. So this is negative 8, x is lesser than negative 8. Over here, x over 1.1 is greater than or equal to 10, x is greater than or equal to 10 into 1.1, x is greater than or equal to 11. So this is 11 greater than or equal, that's a solid circle going to the right. So I hope it's all good, all clear, and the answer is right in front of you. I'm just wondering why is the answer still lagging. I'll just wait. Okay, is this all good, all clear? Okay, let's move on. I hope let me just double check one thing. Let me just stop the recording for a second. So now let's look at example number 2. The question says, solve the inequalities. Give your answer in set notation. We don't need set notation. We just need the normal number line. So this is not exactly for us. So therefore, it's just a normal thing. Let me just solve this question. Part A, negative 2x is lesser than 8. Another example, another way in which the coefficient of x is negative. Method 1, switch the places. So we are not interested in set notation. That is not part of our syllabus. So we are only interested in the number line, but I'm interested in the question. The question is good. Method 1, shift the places. So the less remains. This 8 goes on the other side. This becomes negative 8. This negative 2x goes on the right side. It becomes positive 2x. Divided by 2, divided by 2. And then let's see what happens. So therefore, x is greater than negative 4. And that is the answer for this particular part. I think it's a bit slow. That is why it's lagging a bit. I'll just pause for it so you can look at the recording. So now x is greater than negative 4. That's one way. The other way of solving this question is method 2. That is negative 2x is lesser than 8. Divide both sides by negative 2. Negative 2, the inequality will flip. So therefore, x is greater than minus 4, and that is the answer. This is x is greater than minus 4. This is x is greater than minus 4. Let me draw a single number line. This is negative 4, empty circle, x is greater than negative 4. All good, all clear? Chale, let's move on. Now you have to solve this inequality. Let me mark some of the questions so you can try it out. 4 part A, 5 part E, 6 part E. Try these 3 questions out. So now let's look at these shaded parts. Question number 4 part A. That is negative 3x is greater than or equal to 36. And we are just drawing it on a number line. So divide by negative 3, divide by negative 3. Therefore, the inequality flips. Lesser than or equal, x is lesser than or equal to negative 12. A small number line, not this thick. And this is negative 12. Hold for a second. So now this is negative 12, lesser than or equal to negative 12. Solid circle goes like this. 5 part E. Let me write both of them down. 2x plus 16 is greater than or equal to negative 8. And similarly 6e. That is x over 4 minus 2.5 is greater than or equal to 1. So let me just solve these two. 2x is greater than or equal to minus 8 minus 16. 2x is greater than or equal to minus 24. The coefficient of x is positive, so inequality won't flip. Inequality won't flip. Why? Since coefficient of x is positive. It doesn't make a difference what's on the other side. The decision making is based upon the coefficient of x. If it's negative, inequality would flip. Over here, let me just also pinpoint this thing. So now over here, since the coefficient of x was negative, inequality flips. Why? Since coefficient of x is negative. Doesn't make a difference what's on the other side. So now over here, when I draw a number line, so this is, let me finish this question. Divide by 2, divide by 2, therefore x is greater than or equal to negative 12. So this is negative 12. X is greater than or equal to negative 12. This is a solid circle. Over here, the third one, x over 4 is greater than or equal to 1 plus 2.5, that is 3.5. X is greater than or equal to 3.5 into 4, that is 14. Again, draw a number line, mark over here 14, greater than or equal to 14. That is the answer for the spot. So I hope you all have checked your answer. The first answer is less than or equal to negative 12. The other answer is x is greater than or equal to negative 12. The first one is lesser than or equal. The second one is greater than or equal. The third one is x is greater than or equal to 14. Now, what is a compound inequality? So now let's talk about compound inequality. Now, compound inequality means there are two different inequalities. You have to break it up. It says it combines multiple inequalities into one. So this is one inequality, this is the other inequality. For example, x is greater than 3. This is how you read it. A lot of people have difficulty in pronouncing it. X lies between 3 and 9 inclusive. Do you get the idea? How will we read it? We are writing x lies between. It lies between 3. It lies between 9. Between 3 and 9, that means it's greater than 3, greater than a small number. So this is greater than a smaller number and lesser than a bigger number. But since this is lesser than or equal to, that is why we write inclusive. So let me do one thing. Let me first write different kind of things. X lies between 5 and 11. So I'll write x lies between 5 and 11. Neither is, excuse me, neither is 5 included nor 11 included. X lies between 9 and 20. X lies between 9 and 20, but because of this equality, because of this inequality, I'll write this thing as inclusive because both values are inclusive. 9 and 20, both inclusive. Both is a little bit more pressure on it. X lies between -1 and +5. So this is inclusive. So x lies between -1 inclusive and 5 exclusive. 5 is not included. So even over here, I can write between 3 and 9 inclusive, 3 is exclusive. So these are the different ways of writing a compound inequality. Now over here, how do we solve it? It says solve the inequality -4, in between is 2x plus 2, lesser than 6, show your solution on a number line. So write it as two separate inequality. This is one, -4 and 2x plus 2, this is one thing. And the other thing is this one, that is between this 2x plus 2 is lesser than 6. 2x plus 2 is lesser than 6. Do you get the idea? You solve these two separately. When you solve this one separately, 2x plus 2 is greater than -4. So 2x plus 2, let me write it like this in red color. So this is 2x plus 2 is greater than -4, 2x is greater than -6, x is greater than -3. That's right over here. X is greater than -3. X is greater than -3. So my idea, my methodology is that write the variable on left hand side. So that is what I believe in. So I have written this thing. The variable should be on the left hand side because the left hand side, that is what you make the subject of the equation. So it's easier to read. That's the only thing. And over here, what's the next thing? 2x plus 2 is lesser than 6. So 2x plus 2 is lesser than 6. And 2x is lesser than 4 and x is lesser than 2. So now if I draw it on a number line, so hold for a second. If I draw this thing on a number line, so I can draw it like this, not that thick. And let me write greater than -3 and lesser than 2. So now over here, this is an empty circle greater than -3 So let me just focus on over here. This is negative 3, x is greater than minus 3, that's a red number line. And this is positive 2, this is lesser than 2, like this. And the final answer is such that x lies between 2 and negative 3. So x lies between 2 and negative 3. That is the final answer for this particular question. Is this all good, all clear? Need a little bit acknowledgement and alertness from all of you. Okay, we all learn, yes, negative errors do happen. And yes, I need this thing acknowledged and this thing. Okay, Ji. Good. So now this is all good, all clear. Let's look at this thing. I would like you people to try out 1 or 2 questions. Let's start with this one. That's a good one. Let's start with this one. 1A, 2A, 3A, and something in maybe fractions or decimals. So let me try this out. See. So I'll just pause the recording until you have tried it. Take 5 minutes, try it out, and then I'll show you the solution. So now let's look at the solution of all these shaded questions. So question number 1, part A, let me write it down. 7x plus 3, I can even put a bracket, less than or equal to 15. Then question number 2, part A. Question number 2, part A, that is 16 and 28 and 4x. 16, 4x and 28. And then let me copy this thing on the next page. So that is easier. So question number 1, A, 2A, 3A and 4C. So let me just mark this. That is, hold for a second, why is it not responding? That is 3A and 4C. So 3A and 4C. So 3A, that is 6x plus 5, lies between 17 and 29. And similarly, C, that is negative 8x, is less than or equal to 40 and greater than negative 24. So now let's get started with this. First of all, in this one, I can subtract 3 from both sides. So therefore 7 minus 3, x 15 minus 3. So therefore x lies between, this is 4 and this is 12. That means if I were to show it on a number line, so let me mark the points. This is 12, this is 4. It lies between these two. That's a solid circle. That is an empty circle, and just draw a line connecting the two. That is how this thing is drawn. All good, all clear? Let me focus on this one. Divide by 4, divide by 4, divide by 4. Therefore, x lies between 28 over 4 is 7, 16 over 4 is 4. Again, a number line. Over here, this is 4, this is 7. A line connecting the two. And both circles are empty circle. This is an empty circle. I can just write it over here. This is an empty circle. Third one, 6x plus 5 lies between 17 and 29. So the first thing is subtraction. So 17 minus 5, 29 minus 5. And over here, this is 6x between the two. 17 minus 5 is 12. 29 minus 9 is, this is 6x. I think that is 29 minus 5. Hold for a second, let me just correct myself. This is 29 minus 5, that is 24. Now divide by 6 divide by 6, divide by 6. Therefore, x lies between. This is 4 and this is 2. Number line over here. And then this is 2, this is 4, empty circle, and then a line connecting the two. Similarly, over here, negative 8x. Okay, now this is kind of tricky. Both the inequalities will flip. So therefore, divide by negative 8, divide by negative 8, divide by negative 8. This inequality will flip, this inequality will flip. So therefore, I'll write this will be like this. This will be x. This will be like this. 40 over 8 is 5. 24 over 8 is 3. Again, draw a number line. And this is 3. This is 5. This is empty. This is solid. And just draw a line connecting the two. Now let me explain this. This is 4c in another manner also. So let me do the explanation for 4c alternative way. If someone is not comfortable with that, how can they do it? Minus 24 is less than negative 8x is less than or equal to 40. Treat it as two separate things. Treat this separately. Treat this thing separately. So therefore, our minus 24 is lesser than minus 8x. Shift the places. Therefore, 8x is lesser than 24. Therefore, x is lesser than 3. So this is minus 8x. Let me just double check. Minus 24 minus 8 and 8. Negative 8x is greater than this. So I forgot to, no, I did not forgot. This is lesser. I have taken this to the side, this to the side. So 8x is lesser than 24, therefore x is lesser than 3. Negative 8x is less than or equal to 40. Divide by negative 8, divide by negative 8. So therefore x is greater than or equal to 5. So now over here, there is a discrepancy between the two. If I flip the inequality like this, negative 8x over negative 8, and this is negative 24 over negative 8, that is positive 3. This is negative 5. Hold for a second. This is negative 5 right over here. And I think I mixed up the numbers. So let me just correct myself. This was negative 5. This is positive 3. So x lies between these two values. X is lesser than 3. So this is lesser than 3 and this is greater than or equal to negative 5. So that's how the number line is drawn. All good? All clear? So now over here, let me plot this thing on a number line. That is like this. This is positive 3. That is negative 5. This is negative 5. Don't forget the negative. This is negative 5. And that's the blue line. Let me go this way. And this is positive 3. That is the red line. So now this is over here. This is positive 3. X is lesser than positive 3. X is greater than or equal to negative 5. So therefore the overlapping region is the answer. Overlapping common region is the answer. So therefore x is lesser than 3, greater than or equal to negative 5. X is, it's written other way, x is greater than or equal to negative 5, x is lesser than 3. Officially, this is a better way of writing it. This makes more sense. So this is a better way of writing it. So therefore, in such a scenario in which the coefficient of x is negative and it's a compound inequality, therefore I'll prefer write it separately and then draw inequality on number line. So I think that is a much better way of answering the thing. All good, all clear? So that completes algebra lecture number 21. This is basically inequality part 1. That thing is done. So let me just label over here that this is 21 and 22 will also be over here. So let me, from now on, let me just draw this thing and let me write over here algebra lecture number 22, and this is inequality part 2. So this is inequality and this is part 2, in which we'll be using the concept of graph also. So till the next class, take care.